Tensors are mathematical quantities which are useful to simplify transformations of vectors. Scalars are quantities with magnitude and no direction information. Vectors are quantities with magnitude and one direction information. Tensors are a generalization of this concept. Scalars are a zero-rank tensor. Vectors are a one-rank tensor. A second-rank tensor, which is also called a dyad, is a quantity with magnitude and two direction information. As you're going to see, if you define a coordinate system, a second-rank tensor is a matrix. The mathematics of tensors allow some equations to be written compactly. Let us use an example to illustrate the stress tensor. In fact, this was the first tensor described in physics, and it's where the name comes from: stress, tension, in Latin tensus, and thus tensor. To understand tensors, let's go back to scalars and vectors. So vectors can be multiplied by scalars to produce new vectors with the same direction. For instance, u is equal to lambda v. The vector u has the same direction as the vector v. The quantity lambda simply scales the vector v, which is actually why they're called scalar. They simply scale a vector field. Now suppose that we wish to alter both the magnitude and the direction of a given vector. In this case, multiplication by scalar is no longer sufficient. One thing that we can do is do the cross product between two vectors. Say the cross product between v and w, giving you a vector u. That does change the direction. The vector that you get is in another direction, is perpendicular to both v and w. But as we see, this is not general. It only produces a vector that is perpendicular to both v and w. So form the cross product with another vector is also not sufficient, unless we wish to limit the change in direction to right angles only. We must find and use another kind of mathematical entity if we want, in a general way, change both the magnitude and the direction of a vector.